Okay, today is the first part of Chapter 6, Modular Programming with Functions. Okay, so thus far, we've taken a look at really only, we've used some functions. We use some math functions like sine, cosine, log function. Um, we did like some character checking functions, like is a character uppercase or is that lowercase. We've also looked at some other character functions too. And those are all so-called system-defined or library functions that are already predefined, and you can just start using them. This chapter actually deals with writing your own functions. Right. So far, we've actually written one function. We've written the main function, but now we'd like to break up our program into more parts than that, and we're going to follow this idea of modularity, where we break it up into components, modules or components, and then what we're able to do with that is it supports a lot of things that make it easier to program. Basically, if you have problems with your program, if you can isolate it down into one module or one section, it's a lot easier to troubleshoot and change. Okay, that's what we're going to do. We're going to look at creating our own. So we're going to basically take what could be a long program inside of main, and we're going to break it up into pieces, and we're going to do it with these things called functions. Okay. Now, the next thing we want to look at is parameter passing. It's like you have a function, so you give it information, and with that information, it does some processing and then gives you a result. Like a sine function, we would pass in a radian value, and then the sine function would return the result of that, or an angular value. So that's what we want to do. We're going to pass information in to a function, and that's called what we define this generically as parameter passing. It's defining how the data gets passed in. Okay, the next part of this is so-called return types or return values. So when you have a function perform some operation, it's going to give you some value in the end, or some return value, or some data that it's done processing with. If you do the return type, of course, is that type of that data. So we may have integer, boolean, float, double. And we even have a type where if we don't want to return anything, we call that void. Okay. The last part we're going to do is look at, a couple more things. We're going to look at the scope of variables, right? When is a variable being accessed? We'll look at this probably in the second half, but for tonight, or for today, we'll just look at up to return types. And then we have another thing called the storage class specifier, which we'll look at a little more detail later. Okay. Modularity. Okay. So far, we've had this program. Everything has been written in main. Okay. Now, what we want to do is break that up into pieces. Okay. Or modules. In C++, we call those functions. Or in the C programming language, we call it functions. There's also other ways of programming, like object-oriented ways of programming, and object-oriented programming is a little bit different. They break up things in a little bit different fashion, but for us, for now, we're going to break it up into so-called modules or functions. Okay, so modules. All right. In general, you can think about this like a C++ program. Basic idea: we write our code, we input data, we either take it from a file or we enter it from a keyboard, typically, at least what we've done in this class. And then we've performed some operation on the data, we've analyzed the data, maybe we've performed some calculations, and then we've output some results. Okay, that's generally what we're doing here. Okay, and what we can do is, we can break these up into additional tasks that are performed by some functions. Okay, and it might be that, the input data may not be that complicated, the output might not be too much. But the analysis of the data could be quite involved, right? Okay. All right. So one of the things of breaking up a program into modules, individual modules, I'm a little too far, is that you could have multiple programmers work on a single program. So it could be that, you give a programmer a task, and they are to create a certain module. Maybe they're perform some calculation. So you just pass data to them. They tell you how they want that data. They perform some calculation and give you a result. And all you really care about, if you're writing code in the main, or if you're another programmer writing another module, is you only care about that the information is correct, really, and how information goes in and how it's returned from that function. Okay. Now, testing, debugging, maintaining. If we break it up into modules, of course, it's a lot easier to actually figure out if you have a problem. If you can isolate it to a module, you can have that whoever that programmer is working on it, or you can just break that take that module out, maybe put another one in that you know functions. And that could be much easier when you have to try to figure out what the problem is. Also, updates are much easier too, when all you have to do is focus on that one module. All right. The other part of this is important is this idea of reduced duplication of code. So if you have something operation that you're performing multiple times in your program, you can write one function one time and then do what do they call a function call, and then the function call will execute the code. So you only write the code once, so it makes it a lot simpler. Okay. All right. Functions. So we can think about functions in two main categories. Predefined, those are the ones we've already used. These are in standard libraries. And then the programmer-defined ones. And that's really what we're focusing on in this chapter is, writing our own functions. Although there are predefined ones that we will use, this is the main point of this chapter. Okay. So predefined functions, here was one. So like here's a sine. You pass in an angle in radians, and what happens, this is considered to be like an argument. And this is where you would define parameters, which basically says the type of data that gets passed in here. It could be float, double, boolean, character, could be a string or something else. Okay? When this thing gets executed, what happens is the result of this operation gets placed right in here. Right? The result of this operation, and there's some details behind the scenes that are part of this function that perform the operation for us. Now, if you're writing code in main and you really don't need to know the details behind this, all you need to know that it's accurate, right? So you pass it some information and your expectation is this is going to give you the sine of the angle, okay? So this kind of leaves the details outside of this, which is good because you could have another programmer potentially writing the code for this function, okay? Now, this one's already predefined, and it's predefined in C math, so we can just go ahead and use it. But we may want to write some of our own, which we will in this chapter, okay? So the second part of this is really the main part that we're looking at is programmer-defined functions, okay? Now, here's some terminology that we'll use. And what I'll do is I'll write some code here at the same time to show you how this all works. So we're going to have this so-called function prototype, a function call, function arguments, function definition, and the so-called formal parameters, okay? And there's something about the formal parameters which we'll look at, and this is basically you need to know the number and the data type of these, okay? So function prototype, we're going to need this. This basically tells the compiler that something you've created is a function, all right? And this is needed beforehand before you actually start to use it. Function call. This is the part where you're actually going to make a call to a function saying like run this code that I've defined. Function arguments. This is the information that you pass into the function. Okay? The function definition. This is actually what the function definition is this is the code that you write. You have to write and tell what your function is going to do. And the formal parameters, this is just, you'll see this as the prototype in the prototype and also as the function definition, okay? So what I do is we'll write some code, and very, very basic code, and what I want to do is I'm going to explain each of these parts to you, okay? So I'm going to do Visual Studio. All right, Visual Studio 2019, and I'm just going to do create a new project, and I'm going to do a console app. And next, and create. Okay. And what I'll do here is I'll just delete this part. I don't care about that. And you'll notice it's got this scope resolution operator. If we do using namespace std, we don't have to worry about that. I'm just going to delete this for now. Okay. So first thing we're going to do here is I'm going to do an include IO stream. Okay. So this is just what we've always done for all of our code. Okay, that's good. And then I'm going to do using name space std. Okay. All right. So, and then I'm just going to do system pause. P-A-U-S-E. Okay. Okay. So first thing I'm going to do here is this is where I make the so-called function prototype. So this is called a function prototype. And the function prototype needs to show up before the main function. Okay. And the function prototype, what I do is I have a return type. And what I'm going to do, I'm going to make a really very basic function. And the only thing this function is going to do is going to square a number. Okay. And I'll make it so it squares an integer. So I'll say integer. And I'll call it, the function name is called a square it. And then what I need to do here is I'm going to pass in an integer. Okay, that's my so-called formal parameter list. So in this case, the first integer is a, that's the return type. So first int is return type. That's this over here to the left. Just like we had it here, integer. That's the return type. The second integer between the parens, so int between parens, is the formal parameter. And that's how you pass information into the function. Okay? Through this. And the only thing you're doing here is you're defining how the data is passed in. Okay? All right. So what we'll do down here is we're going to create a value. I'll make a couple of integers. I'm going to call it, I'll just say x is my integer value. And what I'm going to say here, I'm going to say x equals square it. And I'm going to put a number in here. 5. Okay. So this is square it 5. Square it here is the function call. Okay. The 5 in this case is the function argument. Okay. So that's the information you're passing into the function. Okay. So what will happen is square it will run, it'll execute, and then whatever the result of this function is, it's going to be basically substituted right in here, and then x will contain that value at the end. Okay. The next thing I'm going to do is I'm just going to do a cout x end line. End line, end L. Okay. And now what I need to do, now you'll see there's a yellow squiggly line because it doesn't know anything about this. I haven't created a function yet. I haven't done the function definition. Here, down here is the function definition. Okay. So this is actually where it's telling what the function, what it's supposed to do. Okay. So I need to duplicate this. So I'm essentially doing square it again. And I'm going to do integer. And now I'm going to define the actual variable that I'm going to use. And I'm going to call it number. And inside the function, all I have to do is just do number times number. Really not doing much of anything. And then return. Okay? Now, this is the return, so the data type needs to match the data type of what I returned. Well, what I'm returning is just taking an integer and squaring it, and then I'm going to pass it back. So, data type, data type int must match the type in return statement. Okay. So in this case, I'm saying, oh, pass back an integer. So this is the return type. It says, okay, do the calculation, pass back the integer. Okay. So here's the, and this is also this function, the first line here, top line. This is the so-called function header. Okay. This is the function prototype, square it, integer that I'm putting up above the first before the main function. Here is the function call. All right, I'll just do it like this. Okay. And here's the function definition, which includes the, this includes the formal parameters, and then the argument right here, the actual value that you pass in. Okay. So now if I go and run this, I didn't even call it anything. I just called it console application. Should have had a better name for that, but I'll let you define a better name. Forgot to set the name, but okay. So I'm going to run this. And when it runs, you see 25. So let me just expand this out. Properties. Just make it a little larger so we can see it. Okay, there's 25. Okay, so this is a very basic function. Okay, so this is how you would use it. So this is the general process you're going to find with any of these, is that you start off with, you put the function prototype at the top. You do the function call, because if you don't do this function call here, this code that I defined down here will not be executed. Okay, so this is all main. Here's my end of main. This is end of main function. Okay, and then after that, we have my function that it functions. So if you have more than one function, all you would do is just define these one after another. So this is the end of the main function. So this is like the beginning of the main function. Here's the closing curly brace for that block. This is the end of main function. And here's the end of the square it function. It function. Okay. So this is very basic way. This is the most simplest thing, most basic simple function you can write just about. Doesn't do much of anything, just takes information in, performs some calculation, returns that result. X now will contain 25, and then I'm displaying that result. Okay, and that is essentially all there is for a very basic function. Okay, so I'm going to keep this one here. And there are a few more things we want to cover. Okay. Okay. Okay, so this is all the function terminology. And that's the three parts. We need a function prototype, a function call, and a function definition. And these are some subsets of that. Okay, so those are the three ones. Function prototype, function call. If you don't call it, the code is never going to execute. And then at the bottom, you're going to do your function definition. Okay? All right. Okay, so what can you do? You can return a single value if you want to the calling function. You can perform some data independent task. You can modify some existing data if you want to. So the basic structure, you have your return type function name, and then the so-called parameter list, because you can pass more than one thing in there if you want. Okay, and then the date. This is the return value or the data type of that. Okay, so here's some return type: integer, float, character, double, boolean. Those are standard ones that are used. Okay. So value returning function. And that's what I did. I did a value returning function, and you need a return statement in there, so it's required. That's what I did. I returned, number times number in that first simple example. You can also do a void function, okay? And a void function, you don't return anything. So what I'll show you here is that for a void function, I'll create a void function to show you how you can do that. So let me do that. I'm going to create another one. And I'm just going to say void. Here's my function prototype for void. Here's my function prototype. So this is function prototype. So this is at the top. Okay. Void. Display message. Okay. I'm just going to display a message. And what I'm going to do is I'm just going to do this. I'm not going to pass anything in. Okay. So here's my function prototype. I don't have any formal parameters because all I care about doing is displaying a message. All right. So down here, I'm going to do void display message. Open paren, close paren, open curly brace. And here, I'm just going to do cout. Hello, universe. Okay, So here's an example of a void function where I'm not passing anything back. And notice when I call it, I need to call it here, of course. I'm just going to say display message. And notice here that I do not put it on the right-hand side of an expression or the right-hand side of my assignment operator. I just call it directly because there's nothing coming back from this to put into a variable. This one does. This has a integer type, and that goes into X. This one does not, so it's a void. So I'm just going to run this one, and you'll see the result of that. Okay, there it is, 25. Hello, universe. Now, one of the things we'll need to pay attention to here is that what we can do is there's different ways we can pass information into functions. Okay, we can pass it in by or two main ways, anyways. Pass it in by reference or pass it in by value. Now, what do I mean by that? Now, I'll give you a quick example shortly. We'll actually start a new one because this one is starting to get a little bit long. But we're going to look at that. We'll look at different ways of passing information. And there's a little bit of a difference in how they work. Okay? So let's continue here. Current slide. Okay. So we have void function. And there's an example of a void function. So this one just outputs, the square of a number that just goes through a loop from 0 to 10. Okay, here we go. Parameter passing. So we can pass in information to a function so-called by value, which just basically copies the number in, the value to your function, then your function uses it. And the other one is pass by reference. So this one is actually, the way you want to think about this one is that this one passes an address of a variable. So this one will actually make a copy of the variable to pass it in. That's what we did in that first example. This one will actually pass in a address of a variable. Okay. So this is the two types. Okay. So a parameter, right? Special kind of variable. And the information you actually pass is called an argument. Okay. So we're going to look at these. I'm going to do an example of each to show you how this works. Okay. And show you the difference between them. Okay. So I'm going to go and create a new project here because this one's getting a little bit long. File, new, file, new project. And I'm going to create a console app. Next. And then I'm going to call it, I'll just say chapter 6, parameter passing. Okay. And I'll create it. All right. Okay. So, first thing we're going to do is get rid of this. We don't need this. We don't need this. Just going to delete this. So I'm using Visual Studio Community, which is a little bit different. So then I'm going to say using namespace. You may need that, that SDHAFX file. You might need the STDAFX, right? Yeah. File in yours. You may or may not need it. It'll create it automatically for you. But I'm just going to using namespace STD. Okay, so let's see. First thing is, I'm going to create two functions here. And I'll make them both void. Yeah, let me make them both void. Void. And I'm going to call it pass by value. And I'm going to pass in integer for both of them. And I'm going to create another one. I'm going to call this one void pass by reference. And I'll pass in an integer for this one also. Okay. These are my function prototypes. The other thing I'm going to do, I need to do one thing different here. I need to do this. I'm going to put this little sign here, ampersand. Okay, that's what's going to make a difference. This is the pass by value one, which is the same as what we did previously. This one is the pass by reference. Okay. Okay. So what we're going to do is we're going to create a variable. I call it x, and I'm going to set it to 4. All right. Then I'm going to just make a call, pass by value, and I'm going to pass in x. Okay. Then I'm going to do pass by reference, and I'm also going to pass in x. Okay. And let me do this. I'll do a cout x end line. Okay. Then I'm going to do cout x end line. Okay. Now, the first time we call it, we actually pass in a copy of this value, right? So a copy of this variable. So this one will actually pass a 4 into it. Okay. So when we pass a function, we're going to pass a 4. Now, the pass by reference one is a little bit different. Instead of passing in a 4, what it's going to do is pass in the address of this variable, so its location. This one just passes the number 4, and then it goes and creates a new variable, and then it'll actually modify it. This one actually passes in the address. So I'm going to do both of these for you. So void pass by value, and open paren, close paren, and I'm just going to say integer number. Call it whatever I want. I'll say integer number. This is my function definition here. Definition. And inside here, all I'm going to do is this. I'm going to say number plus plus. Okay. And I'm going to do a pass by reference. Void pass by reference. And in this one, I'm going to do the same thing. Okay. And I'm just going to have the function do the same thing. I'm not, number plus plus. Okay. Okay, pass by reference. Did I do something weird? Oh, I know what I did. I have to make this ampersand. This defines it as a pass by reference type. Okay. All right, that has to match this data type. So this actually, when you put the ampersand, it says pass in the address. This one means just pass in a copy of the value. All right, so this one would pass in a 4. This one will pass in the address. So this variable, x, in the main function, and this number are actually the same locations in memory. So what's going to happen when you run it, and you'll see I'm printing it out here, both places. So if I just do a save all, and then I run it. Yes, good thing I have that running. And, oh, know what I need to do? I can do a system pause. I could do a control F5 also, stop it, but I'll do it like this. So let me do it again. Okay. Run it. Okay. And there it is. You're going to get a 4 and a 5. And I'll tell you how this works. Okay, there's 4 and 5. So what happens here is that when you do pass by value, what happens is it takes the value 4, passes it into the function, it executes this pass by value, so it goes down here and runs this code. What it does is then increments 4 and makes it 5. But what you have here is that number is a entirely different variable than x. Okay? It increments it, but it doesn't do anything with it. The function ends. It comes back here and starts executing code right after this line. So what does it do? It just says, okay, print, or pass by value. It says display x. Well, x is 4. I now call it pass by reference, which it passes in the location of x. And then it assigns number, which is this one, to point to the same location in memory as x. So then it points into that location. It updates the value that is at the location x. It increments it by 1. And then when you finish this function, you come back out here. Now it goes and displays the value in x, which because you did pass by reference, you now have incremented that value. Okay, so x now contains a 5. So when you did pass by value, it didn't change x, the calling variable. When you did pass by reference, it did change the value of x. Okay, so this is a very simple example of pass by reference. And so how you know it's passed by reference, you'll see in the function prototype, this ampersand, and you'll also see it in here. Okay, you'll also see it as the part of the formal parameter list. Okay, so that is pass by value. So that's part of our parameter passing. Okay. Okay. So your basic idea, here's the basic difference. When you pass by value, formal parameter reads the value of the argument, and then any changes to that parameter doesn't affect the argument, right? We saw that. You passed in x when you did pass by value, didn't change x. Oh, here's an example of factorial. You can work through this one. This one actually is, well, this is just a function factorial, which passes in n by value here. Okay. Same thing. We did a factorial function. Okay. This is just an example. We could go actually and look, and this is one of the examples I had given in the past. You can work through this one if you want. I don't plan on working through it now, but it's an interesting one, how it actually works and determines a factorial. Okay. So the parameter passing, pass by reference. Now, when you have this ampersand, what it's actually going to do is pass in the, you need this both in the prototype and the function header. It's actually going to pass in the address. Okay, so here's an example, passing in day, month, and year, get date. And so now it actually is going to pass in the address of these variables. Okay. Notice that in this particular one, you have this is the function prototype. Function header essentially is going to look the same, but it has the variable names. In the function prototype, you do not need to put the variable names. You could. It really doesn't matter if you put them in or not. In the function header, of course, which is part of the function definition, you do need the variable names, of course. Okay. So here's an example, and this is actually, I think, similar to the one that it's in the textbook, that one of the examples I asked you to look at. But what happens here is that we pass in two variables, x and y, and essentially we just swap them. Okay, so you have a function, swap function. This is a good example to look at too and try it out and make sure you understand how it works. It's just going to swap the two. So you create a temporary variable, you put one into the other, you put y into x, then you put x into temp, then you take y and put it into the x, then you take whatever's in temp and you put it into y. So basically you've moved the values of those two variables. And so when you actually run the code, what you'll see is that now x will contain 10 and y will contain 5. Okay. Now there's one more example here, a little bit more involved, and this is another one to try and take a look at and check the output. And you can look at it here, and you'll notice that it's different variables passed in by reference or passed in by value, and you could of course pass in any of these. And what you're going to recognize is the first two are passed in by reference, and the last one is passed in by value. So when you look at these first time called, C1 and C2 are passed in by reference, C3 is passed in by value, and you'll see that as it displays what results get changed by this and what do and what don't. So the expectation is C1 and C2 get changed, but C3 doesn't. Okay? And then what you're going to find when you run it again is C2 and C3 get changed, but C1 doesn't. Okay? Just because it's positioned here. All right? Okay. Well, that's good for now. The next part, I'll continue on with part 2.